Hi everyone. Let us see unit number 16, partial and multiple correlation. We are going to see the objectives, introduction, and partial correlation, and what do you mean by partial correlation, and details in that topic, and multiple correlation coefficient, and then details of that one, and 16.4 we are sum up that what we have seen in this unit, and then keywords used in that unit, and terminal questions we are going to see. So the objective of this unit, we are going to describe and explain the concept of partial correlation, and we are going to explain the difference between partial and semi-partial correlation. And similarly, we are going to describe and explain the concept of multiple correlation, and we are going to compute and interpret partial and semi-partial correlation and the test of significance and apply the correlation to the real-time application, real-time data. So then we will compute and interpret partial multiple correlation and apply the correlation technique to the real data. So these are our objectives of this unit. We are now we will move on to that introduction. Already we have learnt about that correlation and the techniques what we have, and we know how to uh, compute the correlation coefficient, that is Carl Pearson's correlation coefficient and the rank correlation, Spearman's rank correlation coefficient, all this. And then we have learnt about that scatter diagram also. And now we are going to see that the concept of partial and multiple correlation we are going to see. So there are correlation coefficients already we have said, but unusual. How to do this one? If it is unusual, then how we are going to do this one under any circumstances? Suppose if you take an example under that. For example, the correlation between the cholesterol level and the bank balance for adults, if it is irrelevant, and let us say we find a positive correlation between these two factors. That's bank balances increases, cholesterol levels also increases. But this is not the correct relationship between cholesterol level and increase in the as age increases. So also age increases, bank balance may also increase because of person can save his salary over the years. So this age factor influences both cholesterol level and bank balance. Suppose we want to know only the correlation between the cholesterol and bank balance without age influence, we could take the persons from the same group and thus control age. But this, if this is not possible, we can satisfactorily control the age factor and thus remove its influence on both cholesterol and bank balance. So this, if done, is called partial correlation. So they are partially correlated. So that's we can use partial and part correlation for doing the same. So to find out the correlation between the similarly we can have, for instance, the academic achievements will be affected by the intelligence, work habit, extra coaching, likewise, etc. So many factors we have. So to find the correlation between the academic achievements with various other factors are mentioned above. So these can be by multiple correlation. So more than one factor we have means, more than two factor we have means, we can, it is coming under multiple correlation. So let us see that partial correlation. Here we are considering that two variables A and B are closely related. The correlation between them is partial. That is the influence of one of the two, more than one variable is also called as partial correlation. So when it is assumed that some other variable is influencing the correlation between A and B, so then the influence of this variable is partially let out for both A and B. So hence it can be considered as a correlation between the two sets of residuals. So here we are going to discuss about the correlation between A and B is partial let out for C. So it can be represented as R A B dot C. So which can be read as correlation between A and B partial laid out for C. So the correlation between A and B partially laid out for move variables as well as. Okay, so this is known as partial correlation we have. So, for example, let us see that example under that partial correlation. For example, the researchers is interested in computing the correlation between anxiety and achievement, academic achievement, um, controlled from the intelligence. Then the correlation between the academic achievement and anxiety will be controlled for intelligence. This can be represented as R academic achievement, A anxiety, B intelligence, and C. So there is a we are representing achievement by A and anxiety by B and control intelligence by C. So the suffixes we are using this A, B, C. So the formula, the computation of this partial correlation by making use of this formula R A B C. So A B O lead out for C. So we can be it can be written as RAB minus RAC RBC divided by square root of R minus AC square into 1 minus RBC square. So here we can make use of this formula in this one. Uh, for example, we have that subject and academic achievement and anxiety and intelligence we have. So, how we are going to find out the correlation between these? So, the data of academic achievement, anxiety, and intelligence for 10 subjects we have. So, we are going to compute the partial correlation between the academic achievement, anxiety, partially partialed out of intelligence. We first need to compute the Pearson's product moment correlation coefficient between all the three variables. We have already learned to compute the first unit of this block. So we are going to see this one. So that is that. The correlation between the anxiety and the academic achievement is already we know how to do the correlation between any two variables. So according to that we can have in this minus the calculation is minus 0.369 we have. So once again we are finding what is the correlation between intelligence and the achievement. So it is 0.918 and the correlation between the anxiety and the intelligence is minus 0.245. So given so here we are going to calculate, so these are these separately. So in that is three session, that is achievement and anxiety and intelligence, A B C we have. So in we have calculated correlation between A and B and correlation between B and C, and similarly correlation between A and C we have measured. So according to that value we are going to calculate partial correlation, that is RAB laid out of C. So that is RAB minus RAC into RBC divided by square root of 1 minus RAC square into 1 minus RBC square. So RABC lead out for C. So we have computed the value. So I can apply this value here. So therefore I can have this minus 0.375. So the partial correlation between two variables and academic achievement and anxiety controlled for intelligence is minus 0.375. So, so we can realize that the correlation between academic achievement and anxiety is minus 0.369, whereas after that partialing out for the effect of intelligence and correlation between them among between them has remained is it's unchanged, it's remained constant. So while computing the correlation, the effect of intelligence on both the variables in academic achievement and anxiety was removed. So the following figure you can see, by making use of the Venn diagram, we can express that one. So academic achievement, intelligence, and anxiety. So we have represented in that uh, Venn diagram we have. So the test of significance of the partial correlation of the null hypothesis H naught is n cap p equal to 0. So the alternative hypothesis H1 is np equal to 0. So t is equal to, here we are applying the t test, rp equal to n minus v divided by square root of 1 minus rp square. So np is nothing but, here it is denoted by denoting the partial population partial correlation coefficient. So n is equal to, here sample size, and v is equal to total number of variables employed for analysis. So the test of significance RP is tested at the degree of freedom in minus v. So here we are using making use of the t-test formula. It is already, it's a familiar one. So t is equal to rp into square root of n minus v divided by square root of 1 minus rp square. So we are applying that value here, and then we are getting 1.69. So we test the significance of this value at degree of freedom equal to 7 in the table of t distribution in the appendix. So we will realize that degree of freedom equal to 7, the table provides the critical value of 2.36 at 0.05 percentage level. So here we obtained this 1.69169 is smaller than this value. So so we accept our hypothesis. So there is NP equal to 0. So for the large sample example, so how we are going to, so we should be aware of that one. What do you mean by large sample and small sample? So large sample is n is greater than 30. We can consider that as large sample. If n is less than 30 means we can consider that as small sample. So here we are going to take a relatively large sample example we are going to consider. So a counseling, for example, a counseling psychologist is interested in understanding the relationship between the practice of study skill and marks obtained. But she is skeptical and about effectiveness of this study skill. So he or that she believes that they can be effective because they are good quantitative techniques, and or they can be effective simply because the subject believes that the study skills are going to help them. The first is the attribute of skills, while the second is the place to effect. She wanted to test this hypothesis, so, along with the measures of hours spent in practicing the study skill and marks obtained, she also took measures on belief that the study skill remaining times it's very useful for her. So, she collected the data and obtained the correlation as follows: the correlation between the practice of study skill A we are considering, and the unit test mark as B 0.69, and the correlation between the study skill and usefulness of, you believe about the usefulness of study skill of C is 0.49. So here AB and AC correlation we have calculated, and similarly the correlation between the B and C, that is correlation between the marks in unit test as well as study skill, usefulness of belief about the usefulness of study skill is calculated, that is 0.391 we are getting. So RAB so dot C equal to 0.625. So the partial correlation between the partial practice study or skill A and unit test mark B is 0.625. Let's the test null hypothesis about the partial correlation for null hypothesis which satisfies H naught. So T is equal to 2.12 we have. Then we have multiple correlation. So the multiple correlation coefficient denoting the correlation of one variable with the multiple other variables. So multiple correlation coefficient is denoted by R. So here more than two variables we are having. So R, A, B, C, D, etc. K, which denotes that A is correlated with B, C, D up to K variables. So, for example, we can consider the multiple correlation between A with B and C. Then it is represented by R, A lead out of BC. So, in this case, we create a linear combination of B and C, which is correlated with A. So we continue with this example, and we will move for that partial and semi-partial correlation. So the example, we have academic achievement, anxiety. Already we have seen academic achievement, anxiety, and intelligence as three variables. So the correlation between the academic achievement with a linear combination of anxiety and intelligence is multiple correlation. So we it denotes the proportion of variance in the academic achievement explained by intelligence and anxiety. So we denote this as the of academic achievement, intelligence, and anxiety, which is a multiple correlation. So we are using the notation RABC equal to square root of RAB square plus RAC square minus 2 RAB RAC RBC divided by 1 minus RBC square. So R into RA over laid out of BC is nothing but the multiple correlation between A and the linear combination of B and C, where RAB is the correlation between A and B. This we will know very clearly. RAC means correlation between A and C. Similarly, RPC is nothing but correlation between B and C. So these are the formulas and notations we are using here. So let us move on to that example. So we shall continue with the earlier data, that is data already we have taken. So we are having 10 data: academic achievement and anxiety and intelligence. The correlation between the anxiety, academic achievement, and correlation between that is intelligence, C. So correlation between C and B is we have, and A and B we have calculated, and A and C we have calculated. So more than one variable if they are we have, so RA over BC. So just we are applying on the formula, so therefore we are getting the value as 0.929. So this means the multiple correlation between the academic achievement and the linear combination of intelligence and the anxiety is 0.929 or 0.93. So approximation we have done. So we have earlier learnt about that square of any correlation coefficient can be understood of percentage of variance explained. So R square is then percentage of variance in academic achievement explained by linear combination of intelligence and anxiety. So this is the example. In this example, R square is 0.929 square, which is 0.865, and the linear combination of intelligence and anxiety explain 86.5 percentage variance in the academic achievement. So already we have converted R into R square. So the R square is the value obtained on the sample. So the population value of R square is denoted by P square. R square is the estimator of P square, but there is a problem of estimating the P square value from R square. So R square is not unbiased estimator of P square. So we need to adjust the value of R square in order to make it as a unbiased estimator. So sum up. So here we will sum up that what we have seen. So here we have seen that correlation, that is partial correlation and multiple correlation, more than, that is when more than one variable or two variables are correlated, more than two variables, then 3 to 4 variables or more than variables are correlated means we can have this as under multiple correlation. So the multiple correlation provides with an opportunity to calculate the correlation of variables and the linear combination of the other variable also. So we can practice that problem. We will have in the terminal questions, so we can understood. So here the keywords, under the keywords we have that formulas, that is the partial correlation as well as the multiple correlation we have. So RAB, that is RAB lead out of C. The formula is given by RAB minus RAC minus RBC divided by 1 minus square root, that is square root of 1 minus R square AC into 1 minus RBC square. See here RAB is nothing but correlation between A and B, or AC is nothing but correlation between A and C, and RBC is nothing but correlation between B and C. So here we are taking the formulas in this manner. So multiple correlation. So R is calculated for two predicate for variable in this manner. So RA laid out of BC is given by R A R RAB square plus RAC square minus 2 into RAB into RAC into RBC divided by 1 minus RBC square. So here once again we are aware of that one. What do you mean by RAB? What do you mean by RAC? And what do you mean by RBC? So we are calculating the correlation between that two corresponding variables we are calculating, and we are applying that values in the formulas. So therefore we are calculating partial, that is a multiple correlation as well as the partial correlations. Okay, so here we have some terminal questions we have. So write that null and alternative hypothesis. Null, what do you mean by null hypothesis and what do you mean by alternative hypothesis for partial correlation? And similarly, calculate the partial correlation between the stress and health control of the effect of coping. And the next third question we have as a test of significance of the relationship. Um, the fourth one, which correlation coefficient should she compute if she wants to control the relationship between the stress and the health? Okay, for the effect of coping only on the stress. And the fifth one is write the null and hypothesis of multiple correlation. So we have the part correlation between stress and health control, and correlation coefficient can be computed if the relation between health and linear combination of stress and coping. So these are the terminal questions under this unit. So practice these questions, and this is the partial and multiple correlation we have. Thank you.